Good morning friends. Today we are going to discuss about one more important algorithm, that is quicksort algorithm. Quicksort algorithm also going to be sort the given number of elements in an array by using divide and conquer technique, right? As I said earlier, divide and conquer technique is mainly used to divide the bigger problem into the smaller problems here. Okay, the problem keep on get divided until and unless a problem cannot be get divided here, right? This is our formal procedure for solving the problems in a divide and conquer technique here. In a quicksort algorithm, this is little bit different from the merge sort algorithm here. What we are going to do here? Okay, initially before starting the sorting the algorithm here, first I need to identify the one element here. That element is going to be considered as a pivot element. Okay, you can select any one element from the given array as a pivot element here, but for making the easy trace and to get easily understand here, and I will take the at the start of the as the end of the array as a pivot element here. Means that in this algorithm I'm going to take the 4 as a pivot element here. Now concentrate here. Once you selected the any pivot element, left hand side of the pivot element should be lesser than the pivot element here, and right hand side of the array should be the right hand side of the pivot element should be greater than the pivot element here. Okay, just to concentrate here, 4 will be considered as the pivot element here. Left hand side of the array 2 1 3 will be the lesser than the pivot element. Okay, I need to sort like this. Okay, 2 1 4, okay, will be get sorted. 2 1 3, sorry, 2 1 3 will be lesser than the 4 pivot element here, that will be sorted at the left hand side of the array. 8 7 and the 6 and 5 are the greater than the pivot element, that will be sorted as towards the right hand side of the array or right hand side of the pivot element here, right? Similarly, how we are going to do that one? Once you selected the 4 element, now we are going to swap this algorithm. Okay, first we are going to take the 4 here. 4 will be the pivot element now. Okay, 2 1 3 will be the left hand side of the array. 4 will be the your pivot element here. Okay, 8 5 7 6 will be the greater than the pivot element. This will be considered at the right hand side of the array. 8 5 7 and the 6 here. Just to concentrate now, I will trace the algorithm later now. Okay, now in the next iteration, what we are going to do? We are going to take the 3 as a pivot element. This will be the right hand side of the array here. 3 will be pivot element. Now once you selected the 3 is the pivot element, as I said earlier, left hand side of the array element should be lesser than the pivot element, so that 2 1 will be the lesser than the 3 here. No need to swap the any element now. Now what we are going to do? We are going to take the 2 elements only. 2 and 1 will be there. Okay, I need to swap these numbers now, because only 2 numbers are there. Left hand side of the array should be lesser than that one, so 1 and 2 will be get swapped now. Here what we are going to do again, 2 will be considered as a pivot element here. Okay, 2 will be there. 1 will be sorted into the 0th location here. You can say this one, the 0th location 1 will be copied now. Second position 2 will be copied already in the, sorry, this is 0, this is 1, and the 2 already in the 3. That means we got the list like this, 1 2 and the 3. Similarly, we are going to apply it to the right hand side of the array also. Okay, initially I am going to take the 6 as a pivot element here. 5 and the 6 will be at the left hand side of the array. Okay, 8 and 7 will be the right hand side of the array. 5 and 6 will be sorted here. Here also 5 and 6 will be sorted. 7 and 8 we are going to get like 1 2 3 and the 4 here. Our array list will be sorted like this. Okay, the important thing here is that we need to select one pivot element now. Once you selected the pivot element, all the left hand side of the array element should be the lesser than that one. Right hand side element should be greater than the pivot element now. Okay, how we are going to partition this algorithm? This is the core technique in this quicksort algorithm. Before going for that, first we are going to discuss about that what is meant by the how the quicksort main algorithm is going to be worked now. Okay, algorithm quicksort. Okay, we are going to take the start index and the end index here. We are going to trace this algorithm until and unless p is less than q here, because this will be the termination condition to call the recursive function here. Divide the problem into 2 sub problems. Okay, partition here. I'm going to take one partition index that will be considered as a pivot element here. This will be given array. P will be the starting index and the q plus 1 will be the end index here. Okay, we are going to call the quicksort algorithm left side of the pivot element. We are going to call the quick sort recursive function to sort the right side of the pivot element here. P to j minus 1, j plus 1 to q here, half of the array and the another half of the array. Very important friends. Now we are going to talk about the partition algorithm. Now concentrate here. Okay, partition algorithm, it is going to take the given array here, start index as well as the end index here. Initially what I said, that one pivot element will be considered at the end of the array. Now can I say this one, the pivot element equal to, pivot element is equal to okay, pivot element is a 4 now. This will be a of end will be pivot now, end will be pivot will be 4 now, a of end will be a of 7 is equal to 4 now. Initially I'm going to take p index. Okay, please concentrate. P index will be start of the array now, p index equal to 0. We are having the one for loop here. We are going to trace the algorithm from start means 0 to end minus 1. End will be 7 here, end minus 1 will be 6 now. If a of I is less than or equal to pivot element, what is the a of I here? 7 is there. 7 is less than or I here? No. Okay, condition get fails here. We are going to come out from the condition. Again I increment the I value by 1. Initially I equal to 0. Now I value incremented by 1 now. Check now. A of 1 means a of 1 is 2. 2 is less than or equal to 4 here. Condition get true. Once it is get true now, swap the numbers. A of 1 how much is there? 2 and p index, initially p index at 2, 0. Okay, a of 1 comma 0 means 2 and 7 will be get swapped now, means we got that one 2 and the 7 here. Increment I value by 1 now. Okay, increment p index by 1 first, right? Means p index now comes to pi equal to 1 now. Increment pi by 1. Check this the condition. A of I, okay, a of I is now 2. Okay, 0 is initially it was 1, it is turned to 2 now. Okay, a of I, it means a of 1 now. Where I did that one, a of 1. Okay, a of 1 is over now. A of 2, a of 2 how much value is there? 1 is there, less than or equal to 4. Condition get true now. Once it is true, that one swap the values 2 1 comma 7. Increment p index by 1 now. What is the p index value now? It is 2 now, right? We got the array elements like 2 1 7. Increment I value by 1. A of 3, 6 is less than or equal to 4. Condition get false here. Increment I value by 1. 8 is less than or equal to 4. Condition get false here. Okay, increment 5 is less than or equal to 4. Condition get false here. Now very important. 6 3 is less than or equal to 4 now. Swap the values. A of 6. A of 6 is 3. A of 2 is 7 now. Okay, 3 and 7 will be get swapped. Now we got that one, this fourth index. We reach the end of the array. We are going to come out from the for loop here. Okay, n minus 1 will be 6 now. We reach that one, come out of the for loop here. Then you swap the index p index with the a of end. A of end will be 4 now. Okay, 4 will be get swapped to 6. I hope friends we all cleared this algorithm. If you are having doubts, any doubts, please send a message in the email or through the WhatsApp. Okay, thank you.